Today's lesson is on writing linear models. I'm going to give you 4 steps to help you through this process. First, define x and y. Second, find two ordered pairs. For example, an xy and another xy. Third, find the slope and y-intercept. And fourth, write the linear model. And today we're going to be using slope-intercept form. Also, you might see it written with f of x instead of y. Example 1, if gas is $4 per gallon, write a linear model for the cost. Then we're going to see how much for 10.5 gallons and also use the model to see how many gallons you can buy for $30. So step 1, we're going to define x and y. So let's let x equal the number of gallons and y be the cost. Whenever possible, I like to let y be the cost. So my first ordered pair, I always like to start with the 0. How much for 0 gallons of gas? That would be $0. How much for 1 gallon? That would be $4. I could continue on, but I don't have to. 2 points is all I need for a linear model. So I'm going to find my slope, 4 minus 0 over 1 minus 0. Now, we would be able to do this without this process, but right now we're practicing the process. So now that I have the slope, now, of course, I'm going to notice here that x is 0, so that this is a y-intercept, and I can write my model. Y equals mx plus b, plug in my slope, and I don't need the 1, but I'm leaving it there for a reason, just for a moment. And now we see y equals 4x is our linear model. I want to make sure you understand what this slope represents. For a linear model, it tells the entire problem. The slope is so important. So remember, slope represents rise over run. However, let's also remember that the rise is characterized by the change in y over the change in x. Later in math, we'll call the change in y delta y and change in x delta x. But we can go back to how we define the problem and say, what does y represent? It represents the money, and x represents the amount of gallons. So this really is saying the price per gallon. Remember, the fraction bar is our per. Okay, so the slope is 4 over 1. So that's saying $4 per gallon. And it just makes sense. And we knew that from the beginning of the problem. So as we continue to work word problems, they'll get easier as you start to realize what the slope represents. Part B says how much for 10.5 gallons. So our answer to part A was right here. So we can take this and plug in 10.5 for the number of gallons. Remember, x is the number of gallons. So I'm going to plug x in as 10.5 or 10.5. Either way is fine. And we see that that is 42. Now, I will ask you to always include units when you answer. Again, y represents dollars. So my answer is going to be $42. That answers the question, how much for 10.5 gallons? Okay, so that's part B. Part C says, how many gallons can you buy for $30? How many gallons for $30? Well, if we use this same model, we realize that the 30 goes in for Y, and now we're solving for the number of gallons. And so we can make quick calculator work of that and see that goes in 7.5 times. But again, make sure you respond with your units. So X represents the number of gallons. So part C, I'm going to say 7.5 or 7.5 gallons. And that would be a good answer. Abbreviations are fine with me. Okay, let's look at example 2. If Hannah buys a new car for $18,000 and makes a monthly payment for 60 months, that's how long it's going to take her to pay the car off. 60 months. Now, notice that I've defined X and Y for you. It says let X be the number of months and let Y be the amount owed. Okay, first we're going to write a linear function for the amount of money owed. Let's make sure that we understand the problem. The cost of the car is $18,000. So remember, X is the number of months. So in 0 months, after 0 months, we still owe $18,000. So that's one ordered pair. After 60 months, the car will be paid off and we will owe $0. So now we can write a linear function once we find the slope. So we have 0 minus 18,000 over 60 minus 0. And that gives us a negative 18,000 over a positive 60. And we see that the slope is negative 300. And what a beautiful thing. Since X is 0, this is a y-intercept. So Y equals mx plus b. This is the answer to part A. That's a linear function. Now, what does the slope represent? Negative 300. Negative 300, I'm even going to put it over 1. Remember, it's the change in Y over the change in X. And we define Y as being the money owed. And that's 300. So that's money owed. And that's 1 represents the number of months. So 300 owed per month. And that explains the negative sign. It's because you're owing it or you're paying it. So that just means that the monthly payment is $300. Payment. You're paying the car place. They're not paying you. So that explains the negative sign. Now, let's look at a brief sketch. And when I say sketch, it's nothing serious. X we want to put on the horizontal axis represented the number of months. And the y-axis is the money owed. When I sketch a graph, sometimes I just use the 2 points that I work with, and it makes for a quick, easy sketch. 0, 18,000. I'm going to let be here. And 60, I'll just let be over here. So connect those 2 points, and that's a good sketch. Okay, we could add some more values, but it's great to always let the origin be 0, 0. So if that's 60, and that's about 30 months there. Ooh, that's messy. And that's about 9,000. And you could even see if you go up after 30 months, you should only owe $9,000. And you see how beautiful this graph is. It makes sense. And notice that the negative slope, the amount owed, goes all the way down to 0. And it takes 60 months to get that amount down to 0. Example 3. In 1950, the life expectancy for women in the U.S. was 72 years of age. 1950, 72 years old. And in 1970, the life expectancy was 75 years old. So right away, I noticed that the life expectancy has increased over time. Write a linear model if X is the number of years since 1950 and Y is the life expectancy. So, as we look at this, number of years since 1950. So, in 1950, the life expectancy was 72, but it says the number of years since 1950, so my X is 0, and the life expectancy is 72. And the other point said in 1970, the life expectancy was 75, so the number of years since 1950 is 20. So there's my second ordered pair. Once we have 2 ordered pairs, we can find the slope, 75 minus 72, 20 minus 0, and our slope is 3 over 20. And I can already see my slope represents 3 years of life expectancy for 20 years. So we've gained 3 years of life expectancy every 20 years. And we could speculate as to why that's true, maybe technology or medical advances. So let's go ahead and finish writing the model. X is 0, so this is indeed a y-intercept. And that's the reason why we use that number of years since 1950. Makes the model nice and easy. So y equals mx plus b. And that's our A, that's our model. And now we're going to use our model to answer parts B and C. So for part B, what should the life expectancy be in 2025? So we need to find our X. The number of years since 1950 is our X. So X equals 75. And we're going to solve for Y. So we can simply plug in X there. Y equals 3 over 20. Plug in 75 plus 72. And we can punch that right in the calculator. And you'll get Y equals 83.25. Now, we do need to make sure we understand what 83.25 even means. Remember, the original problem was defined as Y is the life expectancy. So in 2025, life expectancy should be about 83 years old. And this model is for women in the United States. Alrighty. Units are mandatory, but a sentence is best. Part C. When will the life expectancy be 85 years old? So now we know what Y is, and we're going to be solving for X. So let Y be 85, and let's figure out what X is. So I'm going to subtract 72 from both sides, and I get 13 equals 3 over 20. Multiply by 20 and divide by 3, and we see the reciprocal works out perfect. And if you were to compute that with your calculator, you would get 86.6, repeating. And we say, wait a minute, life expectancy is 85 and 86.6 repeating. And then we remember X represents the number of years since 1950. And when we add that, and a question I often get is, Miss Adams, do we round that up to the year 2037, or do we leave it in the year of 2036? I would say that's probably somewhere in August. So I'd be okay if you were to answer in the year 2036, or I could see an argument if you answered in the year 2037. I wouldn't mark either of them incorrect. Life expectancy will be 85 years old. And actually, I should have said it should be, because one thing we're going to find is that linear models in real life often are not perfect. And many times we have to go with the line of best fit. So should be around 85, something close to that.